Let's begin with problem number 1, which comes from the 2020 AMC 10A number 12. I'm going to assume you read it. So we have a triangle AMC that is isosceles. We're also given that AM equals AC. So the diagram looks something like this. We are drawing two medians now, MV and CU from M and C. And we're given that these two medians are perpendicular and that MV equals CU equals 12, okay? And remember, we're finding the area of triangle AMC. In this case, we should probably be thinking about what a median really means. Well, you know properties of medians. You should know that medians divide each other in a 2-to-1 ratio. And basically all that means is that if we let G be the centroid, right, the intersection of these two medians, then MG to GV is the same as CG to GU equals 2, right, 2-to-1 from the vertex to the midpoint of the opposite side. And we're given that the total length is 12, so it should follow that CG should be like 2/3 of that 12, that length of 12, whereas GU would be only 1/3, right? So you can see that we have an 8-to-4 division, so that CG equals 8, G equals 4, and similarly MG equals 8, and GV equals 4. From this, we can get that the triangle, we can get many of the other lengths in the triangle, right? Because these two medians are perpendicular. In fact, we can easily see that within triangle GMC, we see that we have an isosceles right triangle, so therefore the hypotenuse MC should be 8√2, right? And we can also see that given legs of length 4 and 8 in triangle GMU, we get UM equals square root of 4 squared plus 8 squared, and that's going to equal to 4 times the square root of 1 squared plus 2 squared, which you can see is 4√5. And we can actually fill these in as well. So you can see that the length AM is equal to, well, 2 times 4√5 or 8√5, because you remember U is a midpoint of AM. So AM equals 8√5, and now we just have a triangle, right, an isosceles triangle, and we know both of its two lengths, right, all of its lengths, 8√5, 8√5, and the base, remember if you go up here, the length was 8√2. So now we have basically all the things we need to find the area of this triangle. As always, when you want to find the area of an isosceles triangle, we always want to find the height, right? Because we already have the base. And to do that, we use the Pythagorean theorem. Note that the altitude bisects that base. So we can get, if this is h, then h squared plus 4√2 squared equals 8√5 squared, right? And so this is like 32, and this is equal to 320, okay? So we eventually get that h squared is equal to 288, and notice that that's 2 times 144, so h is equal to 12 times √2. And then the area of AMC then, right, must equal half times the base, 8√2, times 12√2. See that that half cancels with the √2's, and we get a total answer of 96. Now let's go back up. Let's see which answer choice that is. Answer choice number C.